Hello students, in the last class we have discussed about the various work transfer process in thermodynamics, and today in this class I will discuss with you about the PdV work in various quasi-static process. So the first process is here constant pressure process. So what is constant pressure process? The constant pressure process is that kind of process in which pressure remains constant throughout the process. So in the PV diagram we can see here that when the state changes from point 1 to 2, the pressure remains constant, but only the volume changes from V1 to V2. So from the expression of displacement work or PdV work, we can write that W equals to integration of PdV. And in this case, from the figure, we can see that the pressure remains constant throughout the process from 1 to 2. So, and only the volume changes from V1 to V2. So, upon integration, we will get that the expression will be P into V2 minus V1. That means pressure into final volume minus initial volume. Then we come to a constant volume process. The constant volume process is that kind of process in which the volume remains constant throughout the process. So from the figure we can see that in this case the volume V remains constant, only the pressure changes from P1 to P2. So the expression of the PdV work, which we know as integration of PdV, and as the volume remains constant, so we can write that the dV, which is a change of volume, that is equals to 0. So the whole work done in this case become 0. This constant volume process also termed as isochoric process. The next process is PV equals to constant or isothermal process. So if PV equals to constant, so we can write that PV equals to P1 V1, which is also constant. So we can substitute P as P1 V1 by V equals to constant. And from the equation of PdV work, we can write that W equals to integration of PdV. So if we substitute the value of P here in this equation, we will get that work done from 1 to 2 is equals to P1 V1 ln V2 by V1, or we can write it as P1 V1 ln P1 by P2, as the process is PV equals to constant. The next process is PV to the power n equals to constant process. So in this process, as PV to the power n equals to constant, we can write that PV to the power n equals to P1 V1 to the power n equals to P2 V2 to the power n equals to constant. So if we substitute the value of P from here, we will get P equals to P1 V1 to the power n divided by V to the power n. And the expression of the displacement work or PdV work, as we know, that is the integration of PdV. And if we substitute the value of P here in this equation, we will get P1 V1 to the power n by V to the power n dV integration. So upon integration we will get the value like this, and if we put the value of V1 and A2, then we will get the equation like this. So now the thing is here that we have to remember that in the next step, when we are going to multiply this P1 A1 to the power n with the V2 to the power 1 minus 1, we will substitute this P1 V1 to the power n with the value of P2 V2 to the power n, because as we know that the process is PV to the power n, so it is clear that P1 V1 to the power n also equals to P2 V2 to the power n. So in the next line, while multiplying with A2 to the power 1 minus n, we substitute the value of P1 V1 to the power n with P2 V2 to the power n, and this is for the ease of calculation. Okay, and after calculation we get that the equation becomes P2 V2 minus P1 V1 divided by 1 minus n, or we can write it as p1 v1 minus p2 v2 divided by n minus 1. And in this PV diagram we can see that as the value of n changes from 0 to infinity, how the curve or the slope of the curve changes.